Hello friends, this question is for the test series number 5. The subject name is communication, the topic name is noise in analog communication, and it's a 2 marks problem. The question is very interesting and says that a pentode having an equivalent noise resistance of 5 kilo ohm. Okay, the equivalent noise resistance is 5 kilo ohm, which specifies here as Rn, is selected for the operation as an amplifier with a signal source of 100 microvolt. Okay, we have an amplifier with the signal source of 100 microvolt, and the internal resistance is 125 ohm, 125 kilo ohm. The internal resistance of the source is 125 ohm. You know that every practical source has a series resistance, which in this case is 125 kilo ohm. The grid leakage resistance is 175 kilo ohm. Okay, there is another leakage resistance of 175 kilo ohm. Then the bandwidth is given as 10 kilohertz and the temperature is 27 degrees Celsius. Okay, then we need to calculate the SNR for the output. So friends, we know that in case of noise, the noise voltage Vn is defined as 4k T bandwidth times R equivalent. Okay, this is the noise voltage. Okay, this is the expression for the noise voltage. So in this expression you can see that K is a Boltzmann constant. Okay, so we can see that the constant temperature is given to us 27 degrees Celsius, bandwidth is given to us 10 kilohertz. The R equivalent is the equivalent input resistance, because we are talking about the input SNR at the output of the amplifier. Okay, because we need to calculate the output SNR, but the question says that amplifier is noiseless. So whatever SNR of the input side, whatever SNR we have in our input side, will going to present in the output side, because the amplifier is not going to apply or provide any additional noises. Okay, so basically we will just calculate the input signal power and the input noise power, and we'll calculate the SNR of that. That will be my output SNR. So my input noise voltage will be the Vn under root of 4kT bandwidth of R equivalent. So I think we already know all the parameters. Only thing is we need to find out the R equivalent, which is the input R equivalent from the input side, which we will see that is going to be the 125. Okay, which will be, you need to calculate R equivalent at this corner, because basically we are calculating noise here, noise signal here, and the input signal here, because beyond this point there will be no additional noise. Okay, so I will just calculate noise voltage at this point only. So my R equivalent will be 5k plus parallel combination of 125k and 175k. Okay, this will be my equivalent. So my equivalent resistance will be 78 kilo ohm, 125 kilo ohm parallel 175 kilo ohm plus 5 kilo ohm. So my equivalent resistance will be 78 kilo ohm. Rest we already know. So let's calculate the noise voltage, which is 4 into Boltzmann's constant. We know that it's 1.38 into 10 raised to the power minus 23 multiplied by temperature. Temperature we always put in the Kelvin. It is given here in the degree centigrade. So just add 273 plus 27. That will be in the Kelvin. Then bandwidth is given in the 10 kilohertz. 10 into 10 raised to the power 3. R equivalent we have just calculated 78 kilo ohm. 78 into 10 raised to the power 3. Okay, so just with the help of Kelsey we'll just calculate this noise voltage. It comes out as Vn square is coming at 1.29 into 10 raised to the power minus 11. Okay, it is Vn. Let's take a Vn square, so under root will come out as 1.29 into 10 raised to the power minus 11. Similarly, we can calculate the source voltage also. Supply signal is given to us as 100 microvolt, so Vs square will be 100 micro whole square, which is 10 raised to the power minus 8 volt square. Okay, because micro is 10 raised to the power minus 6, so you will have 10 raised to the power minus 8. So the SNR is defined as 10 log 10 Vs square upon Vn square, because a normalized signal power upon normalized noise power for resistance is equal to So you will have, just put this value 10 of log of 10 Vs square 10 to the power minus 8 upon 1.29 into 10 to the power minus 11. So you will get it as 28.88 dB. So the SNR for this system is 28.88 dB. So now for this system is 28.88 dB. Thank you.